So welcome to the introductory lesson in the course Parallel Functional Programming with Java and Android. What I'm going to do today is give you an overview of the course and talk about some of the logistics you'll have to understand as we go through the semester together. So I'm going to give you a quick rundown on the course philosophy, the contents of the course, how the lecture material will be structured. I'll give you an overview of the assignments and how we'll be assessing the assignments. I'll give you some hints about how to set up the Java and Android IDE on Android Studio, which should be fairly simple these days because it's pretty much turnkey, knock on wood. And then I'll give you some tips on how to access the Android and Java source code, and then we'll wrap up. So why are we teaching a course on parallel functional programming for Java and Android? Well, the starting point for this, of course, is the fact that there's now a whole slew of platforms that have multi-core processors. So, of course, servers have lots of processors, multi-core processors, desktops, laptops, even smartphones these days increasingly have multi-core processors. I'm currently running on a Mac that has 8 cores, and I've got a Windows machine that has 6 cores, so it's pretty hard to find single-core processors anymore. Now, once you've got all this power at your disposal, the question arises, how do you take advantage of it? And so that's really what this course is about. We're going to be using Java because Java has excellent support for multi-core programming and parallel processing, and we'll see it from a whole bunch of different points of view as we'll outline momentarily. And we'll be focusing on Android because while Android is not a server by any means, as I mentioned before, a lot of phones have access to multiple cores now. But more importantly, Android gives you a way to learn how to do parallel programming using a form factor that's easy to work with. You may have an Android phone. Even if you don't have an Android phone, it's easy to install the Android emulator. And so you can learn about the principles and methods and tools of parallel programming in a device you can literally hold in the palm of your hand. So that's really cool, and I think you'll enjoy learning about how to work with Android, and it's just fun, and the assignments are really cool. The reason why we have so many cores is driven to some changes in computer hardware. So up until about maybe 15, 20 years ago, every 18 months to 24 months, the clock speeds on processors would double. And this is what's known as Moore's Law. Except Moore's Law doesn't really say the clock speeds double. It says the number of transistors on a chip double. Well, for various reasons, we've kind of hit a wall where chips aren't really getting any faster. They've kind of maxed out at a certain level, but they still have all those processor cores. So what's happening nowadays is that instead of trying to make things run faster, people are dedicating these extra transistors to have more cores on the platforms. So now we're having lots of cores, and that, of course, raises the question, how do you program all those cores effectively? And in this course, I will give you a little snippet of the history of the evolution of these technologies over time, and you'll get a feeling for why we've ended up where we have, focusing on parallel functional programming and reactive programming as the models for taking advantage of all these processor cores that we now have. I've been teaching programming for a really long time, going back to the late 80s, and it's been my experience that learning how to program is not just about reading papers and reading books and thinking deep thoughts. It's really about trying out these tools, these languages, these platforms on actual programs and interesting, fun programs, not just little trivial toy programs. So what we're going to be doing here is we're going to see a lot of examples of how to write parallel functional programs using Java on Android. And the goal is to be able to learn how to make the programs easier to read and write, easier to maintain and modify, and also, of course, because it wouldn't make any sense otherwise, more efficient and resilient. And the way we're going to do this is by applying time-proven patterns and object-oriented and functional design and programming techniques. So this course has lots and lots of hands-on programming. You will get plenty of experience, plenty of a chance to take the concepts that we discuss in the lectures and on the videos and the readings and so on, and really try them out in the context of the assignments. So let's talk about what the course is going to cover. So there are going to be 3 major topics related to parallel functional programming. We're going to talk about something called streams and parallel streams, and that'll be one of the first things we talk about after an intro. And then we're also going to be talking about some other interesting dimensions of this, things like the Java Completable Futures framework, which is a really interesting way of doing asynchronous processing. We're also going to be talking about something we're also going to be talking about the Java reactive streams model and a couple of the different implementations of reactive streams, namely the mechanisms having to do with RxJava and Project Reactor. So those are really the major ways in which we're going to talk about these capabilities. Then we're also going to talk initially at the beginning about modern Java features. And these are features that you probably have not been exposed to if you've taken CS 1101 here at Vanderbilt, where the focus is primarily on object-oriented programming. So object-oriented programming deals with things like classes and inheritance and virtual dispatching, virtual method dispatching. Whereas functional programming, as we're going to see here probably later today, in fact, if not today, for sure next time, will focus on things like lambda expressions and method references and functional interfaces. So that's going to be the initial focus, and we need to have that information because it's hard to understand a lot of the cool features in the parallel frameworks in Java without knowing some of that background. We're also going to talk about software patterns for parallel programming, and these are, of course, very important because it's not enough just to know how the language features work or the frameworks and platforms work. It really helps to know the underlying microarchitectures and common roles and responsibilities you find when you program using these abstractions. And this is quite valuable because undoubtedly over time you will do parallel functional programming with other languages besides Java. And by learning the patterns, it will give you a way to transfer your knowledge to other platforms, other languages like C# or, God help us, JavaScript and other things like that. I'm assuming here that I'm assuming that you know Java as in the kind of Java we teach in CS 1101, which is the object-oriented stuff. So I'm not going to spend any time on that. I'm also going to assume that you'll be able to figure out enough Android in terms of running the examples in the emulator on your own. It's not very hard, and we'll give you tips and pointers. And I'm also going to assume that you can figure out how to use Git. If you need some refresher or you feel a little rusty in that, you might want to take a look at our Coursera specialization, which is a way of, for free, learning about these things, Java for Android, Android, and Git. So take a look at the link down at the bottom if you need a refresher there. And of course, feel free to post any questions you have to the Piazza memo board, and we'll be happy to help you there as well. So there are three main modules in this course. The first part, which we'll talk about starting likely today, is Java's functional programming features. And as I mentioned before, those will be lambda expressions and method references and functional interfaces. And I'll spend probably the first couple of weeks on this topic, and you'll get a chance to try out these features in the context of some programming assignments we're going to do. I'm assuming that you already understand the object-oriented part of Java. If you've never programmed in Java and find it very hard to program in Java, this is probably not the course for you, quite frankly, because we're not going to spend any time covering Java quad Java. So I'm assuming that you know that. The bulk of the course is going to focus on the parallelism frameworks that you get with Java, and this will include, again, sequential and parallel streams. Once you understand sequential streams, parallel streams is quite easy to understand, so that's where we're going to start after we do the functional programming part. We'll talk about Java Completable Futures next, and then we'll finish up the class with a focus on so-called reactive streams, which are really, really cool. And this is material that I haven't done in this class before, so this is all brand new from this year, and so you'll get a chance to learn these really interesting new features, which are very, very popular in the context of Android, by the way. And then throughout the course, we won't have an explicit focus on this, but throughout the course, I'll also be talking about software patterns for parallel programming. And the way this is structured is each of these modules is composed of a bunch of lessons. Each lesson is composed of parts, and each part will be a single lecture. And I'm going to split everything up after class. I'm going to take the videos that we're recording, and we're going to go ahead and turn them into short videos, maybe 5 to 10 minutes, except probably for this one, which will be longer. And those will be uploaded to the lectures link in my website at my Vanderbilt account. Now we're going to be using Brightspace in this class, but only for the online quizzes. We're not going to be doing, the videos will not go into Brightspace. They're going to go into YouTube. The actual course descriptions and the slides and all the other things are going to be elsewhere for a whole variety of reasons, which I'm happy to go into more detail if you have questions. But this portal here at the bottom of the slides is the place to start. And I'll give you pointers on how to navigate all that stuff here in just a second. And what we're going to do here, I learned some cool stuff in the last week. YouTube now has this interesting feature called Progress Bar. And what it allows you to do is it allows you to have a little table of contents in your videos so you can jump from section to section very easily by clicking on the time segments in the description portion of the video. And so I'll be using that, so it's real easy to navigate through the videos and find out what you want to find out. And that's going to be important because, as you'll see, we have bi-weekly quizzes in this course, and the best way to study for them is to go back and watch the videos. And so it'll help to have the videos indexed nicely using the progress bar feature. Little recap, there's bi-weekly quizzes on the material we cover in the lecture. The first quiz will be on Wednesday, September 2nd, so that's a week from this Wednesday. The quizzes will be done online in Brightspace, their closed book, and to make it, so it's not sort of just copy and paste and go back and read the notes, the quizzes will often contain program snippets where I will say something like, here's code that doesn't work. Please explain why and describe how to fix it. And you'll see you're going to get a lot of that when we go through the frequently made mistakes from the programming assignments. I will be giving tips and feedback on common problems. And so if you watch those videos, which I'll also record, then you'll be in good position to understand how to study for the quizzes and do well in the quizzes. We are going to do our best to try to get the quizzes graded and handed back to you by the start of the next class. So quizzes are always on Wednesdays, and then we will hopefully get them back to you by the following Monday, and then I will go over the solutions in class. I will not record videos of the solutions, so motivation to come to class to find out what the answers were for the quizzes. And this is one of the benefits of having a slightly smaller class. We have about 40 people in this class, but that's slightly smaller than the typical Vanderbilt CS class these days, which is good. I recommend that you study for the quizzes by reviewing the slides and watching all the screencasts that I'll be uploading to my Vanderbilt account. And these will also all be located in a YouTube playlist. And so you can get this information a couple ways. If you go to my website here, then you'll get pointers to the playlist and PDF versions of the slides. If you just go to the playlist, you'll just get the videos. So either way works just fine. And the other thing to do is make sure you watch the videos that go through frequently made mistakes of the assignments. And we'll talk more about how we do the review in a second. Depending on how things go, we might have a cumulative final that will be focusing really on the last couple of weeks of the class, but in theory it could cover anything, but it usually covers the last couple of weeks since the previous quiz. And the exam is formally scheduled for Tuesday, December 10th, and it'll of course be on Brightspace. What I typically do, especially if people are going to be in different time zones, what I've done in the past is I've given people like a 12-hour window in which to do the 3-hour exam, and we'll probably do the same thing for quizzes as well. Just give people a window of time, because I know some of you are working remotely and living remotely, and so rather than making everybody do crazy things to conform to the Procrustean bed of the schedule for the class, we'll probably have the quizzes over a period of time. We'll see how that goes. The reason why the exam is optional, or might be optional, is that depending on how the final assignment goes, we might spend more time on the final assignment. It kind of depends on the time frame for everything. So there might be a final, there might not. So let's talk about the assignments and the assessments. All the programming assignments should be written on Android Studio using API level 30, and I'll talk more about that in a second. That's the latest and greatest version of Android, Android R. And of course, you'll be using Java 8, which is the version of Java that's supported in Android. For various reasons, Android doesn't support the latest versions of Java. I think Java is now up to Java 14. So the good news is that the key features we're going to cover that are kind of the modern Java functional programming features are supported on Android. And so you should be in perfectly good shape to take everything we talk about with modern Java and apply it to the programming assignments. You're welcome to use another interactive development environment to develop your code if you want to. Not quite sure why you'd want to, but you don't have to use Android Studio if you have a different choice, but your final implementation and submission has to work with these versions of Android. Luckily, the Java 8 runtime environment now comes pre-installed on Android. You don't have to do anything special in order to get it. There's some links at the bottom of this slide, which you can find at my GitHub account. We'll go through that in a second. And that will give you pointers on where to install the software and how to install the software. It's actually pretty easy these days. You have to use Android Studio to submit your solution. And I recommend that you learn Android Studio. It's actually a very nice environment nowadays. It's got all kinds of cool things. We're not going to use all the cool features of Android Studio as much as we would like to if this was really an Android course. This is really a parallel functional programming course that happens to use Android because it allows us to do really cool GUIs for our programming assignments to make them more interesting. You don't have to know the details of how those things work, but you will know how to, you most likely will have to know how to run an emulator, how to install and run an emulator on Android. Probably should learn how to use the debugger and so on. Those are things you'll need to do even if you're not doing lots of Android GUI development. As I mentioned before, please install API level 30. This is right now, if you download Android Studio and you go in and open up the SDK manager, you'll see that it's currently listed under something called Android R10 Plus. And that's basically a pre-release version of Android 11. I think Android 11 is slated to come out roughly the first week or so of September, so it's in a week or two. I didn't want to hold us back by using an older version of Android, so we're going to go with Android 11, but be aware you may have to start out with Android 10.5 or 10 Plus. For those of you who've ever seen the classic movie, This Is Spinal Tap, the Android 11 logo is a pun on one of the themes in Spinal Tap where the amplifier goes up to 11. So that's the joke there. That's why it looks like a volume knob that goes up to 11. All the source code for the assignments and the examples will be available at GitHub. And so there's links on my course website to these sites. But if you go there, you'll find the assignments. Right now, assignment 1A is the one that's there. I'll be releasing the new assignments, and there are instructions in the wiki links on how to go ahead and update your code base. And we'll talk about that more in a second as well. You'll need to learn how to use Git and GitLab. Many of you may already have a GitLab account from other courses. If you don't have one, it's real easy to get one. Make sure that you set your visibility settings to private, because only myself and the TAs/graders should be able to see your code. Other students should not be able to see your code. We're going to try to do our best to make sure that the assignments that go up are in good working order, but occasionally you'll have to refresh your repository if things change, and you'll certainly have to refresh your repository when I put new assignments out. And there are some instructions on how to do that, a couple different places in the wiki links on the website for the course in GitHub. So I have my code in GitHub because my code, my skeleton code, is intended to be open source so you can get it. Your code will reside in GitLab, but luckily it's not hard to go back and forth between those different versions of Git. The assignments themselves will give you a whole range of experience with cool Java 8 features and Android support for parallel programming. And so this link down here is actually not correct. I will fix that when I redo these slides. You just want to go to the CS253 part, and that'll take you to the assignment. The assignments are all going to build on each other, so they're cumulative, and they're going to give you experience with Java's functional programming features like lambda expressions and method references and functional interfaces. That's the first assignment 1, which is intentionally very, very easy. And then we're going to have sequential and parallel streams assignment. We'll have a completable futures assignment, and then we'll wrap up the semester with a reactive streams assignment using RX Java, or more specifically RX Android. And the particular assignment is really cool, and especially cool because the graphical user interface is so interesting, and it basically allows you to download a bunch of images from some starting URL, which in this case is my website by default, And then it visualizes the downloading and the transformation of the images by applying various image transforms or image filters, and then finally storing the images to disk. And you'll really literally get a chance to see the benefits of parallel programming and all the different models we'll use, because you'll be able to visualize as the program runs exactly what the speed ups and acceleration and scalability properties are by using parallel computation. And this is particularly beneficial if you have a laptop or desktop, whatever you use to build the projects that have multiple cores. You'll really see a difference between the sequential version and all the parallel versions. Now, the way in which the programming assignment assessment is done is probably a little different from what you might be familiar with from other courses. If you've taken another course by me, this is not unfamiliar at all, because I always do it the same way. But basically what we do is we start out with an initial submission, which is not graded, but it's simply reviewed. And I'll talk about the process here in a second. Very, very, very important to remember to submit your initial version. Very important. If you do not submit the initial version, you lose major, major points. And I'll talk more about why we do things this way as we go through the process. So this is a little diagram that kind of shows how the various steps work. So there's going to be an assignment due date, which all the assignment due dates are always up on the wiki page in my GitHub repository, which you can get to from my website. And when the initial submission is due, you have to submit a good faith version of the code. And by good faith, it needs to compile, and it needs to do a pretty darn good job of trying to implement things. If you just throw crap in there, you're going to lose a lot of points. So don't do that. Make sure that you take your shot at making things work for the initial submission. I then go through and review everybody's program and give you comments and feedback for improvement. And then I will push those revisions back to your GitLab repo, which means that you have to tell me where your repo is. We'll talk more about that in a second. And then I will go ahead and create a video that walks through the frequently made mistakes for what I saw people do. And I will go ahead and post that video. And then you'll have a certain amount of time, probably maybe a week or so, depends on how complicated the program is, maybe a week or how hard people were struggling to make things work. You'll have about a week to address my comments, and then you go ahead and resubmit your code by the actual due date, and then the TA and graders go off and they will review it and give you a grade. So everybody should do quite well as long as you follow along and follow the directions, because you're going to get feedback, you're going to get personalized feedback. I will summarize the typical problems I saw, and you get a chance to come back and ask questions in office hours and on the Piazza forum and so on. So you should be in a good shape to do well, but you just have to make sure you keep up with the class assignments and the due dates and so on. Now, it turns out that with Zoom, there's a feature that allows me to know who attended each class. So it's very important you come to class. If you don't attend class, if you decide to blow it off, then you're going to lose points on your assignments. And if you take a look at the link at the bottom of the page, it explains kind of the policy and process for that. So make sure you attend class. We'll talk more about participation here in just a second. Hopefully it goes without saying, but I'll say it anyway. The work that you submit needs to be your own work. You shouldn't be sharing. This is not a team-based course. It's not a team-based project course. It's a course that focuses on individual assignments, and that goes for both quizzes and also for the programming assignments. So please go back and read the honor code if you have any questions, and obviously feel free to reach out to me if you have questions too. There's a rubric for doing the evaluation. You'll see that all the programming assignments have unit tests that we run, and we actually have an auto grader that goes through and will check to see whether your code is conforming to our expectations of how it should work. And because you can run those unit tests, then you should have a very good idea by the time you submit both your initial version and your final version how well you're going to do. So there should be few, if any, surprises with respect to how you're doing in the course on the programming assignments. We'll, of course, give you a grade, but you should be able to tell by running the auto grader and the unit test how you're doing. This is a rough estimate of what the relative weighting of each portion of the course will be. The quizzes, there'll probably be maybe 6 or 7 quizzes, are 40% of the grade. The programming assignments, there'll be 4 programming assignments, roughly 40% of the grade. If we have a final exam, that'll be 10%, so it's roughly about the same as a quiz, maybe a little bit more than a given quiz. And then there's also a participation score too, and I'll talk about that in just a second. We might change the weightings a tad. If we don't have a final exam, we'll probably bump up the quizzes and the programming projects to be 45% each. So what is participation? Well, it's kind of a combination of things. First, it's attending class, which I can monitor through Zoom, and then participating, asking questions in class, asking questions on Piazza, coming to office hours. And then it's also something that I call following directions. And it's very important to follow the instructions. So I will be putting out a Google form. I will put a Google form out. I will send the Google form to the Piazza list so that you'll know it's there. And you need to fill out the Google form to let me know where you've put your code and that you've got it working and that you did a good faith effort to make it work. It's very important to fill out that form. If you don't fill that form out, you lose points. So make sure you follow directions. If you're the kind of person that just cannot be bothered to follow directions, this is going to be a very frustrating class for you. I guarantee you that. Likewise, if you're a person who just doesn't want to be involved, just wants to be a bump on a log, this is also not a good class to be in. So I really want people to be involved, asking questions. That's what makes Vanderbilt students. That's also even more important nowadays that we don't have the luxury of meeting each other face-to-face in as traditional a way as we have done in the past. So don't expect to get an A if you don't participate. And participate means attend, be involved, and follow directions. So I'm really a stickler about that. I'm pretty helpful in everything else, but if you just don't want to follow directions, it's going to be unpleasant. So be aware of that. Setting up the Android Studio environment, it's really pretty simple nowadays. Go to this link and it'll prompt you to download Android Studio for whatever platform you've got, be it Windows or be it Mac. You can also use Linux, but I would probably recommend sticking with Windows and Mac because they're a little bit more widely used. And you'll find that it pretty much should install out of the box. Let's talk a bit about the installation steps. So you go and grab the latest version, which is version 4.x. Whatever the latest version is, whatever the version is that's at that link, that's the one you want. And so it might change over the course of the semester. You should be fine as long as you got version 4.x. Then what you want to do is you want to launch the Android Studio SDK Manager. That's one of the menu options you have if you select the menu from the top under, I think it's under Tools. And you want version R, and that's going to be either version 10 plus, which is what it is at the moment, and then in a couple weeks it'll be up to version 11. So it's API version 30. So make sure you install that, and there's some instructions here to take a look at. And then make sure that you also create the Android API 30 emulator. Now, if you're fortunate enough to have a phone that's running Android 30, which probably isn't the case, then you can run the assignments on your phone, which believe me will be blazingly fast. But most of us, including myself, don't have Android 30 installed on our phone yet, so we'll have to use the emulator. The good news is the emulator works pretty well. If for some reason you have a really, really old laptop or desktop that just doesn't have the horsepower to install and run Android and Android Studio efficiently, please reach out to me. Please post on Piazza and we will find other accommodations. There's a computing lab that's in Featheringill Hall that you may or may not be able to access locally, but you should be able to access it remotely, hopefully. And we can install Android Studio there so you can use it there, which should have plenty of horsepower. I installed Android Studio just yesterday on my Mac, and it automatically enabled something called the HACSUM optimizations, which make things run way, way faster. I'm not sure because I haven't installed it on Windows recently whether it does that automatically for you. It does that automatically on the Mac install. It probably does it also on Windows. But if it's not installing automatically, go ahead and take a look at this link and make sure you enable the HACSUM virtualization driver, which really speeds up the emulator. Basically lets it run pretty much at native speed. If you don't do this, you will be very frustrated because it will be glacially slow and you'll be cursing the day that you had to use Android. The good news is that the way we've designed the assignments, by and large, you just have to be able to run the unit tests, which don't require using the emulator. So as long as your unit tests are passing, if your emulator is a little bit slow, not the end of the world. You just won't get a chance to see all the cool graphics running in real time the way you would if you were using the virtualization driver or a faster machine. One of the other cool things about Android and Java, they're both available in open source form, so you can get the source code for Android for browsing and downloading. We probably honestly won't really need it for this course, but it's just nice to know it's out there. And then you can also get the Java source code for browsing and the Java source code for downloading. That I would recommend you do. That's really cool. We will walk through some of the source code in this course, and I think you'll enjoy learning how it works because it's very cool. Okay, so to wrap up this introductory part, you will get out of this course what you put into it. No surprise. Be prepared to work hard. I think you'll learn a tremendous amount of interesting things, but the programming assignments will come at you pretty fast. I try to have something due pretty much every week or so, or every other week. And you'll see that the way we do things, we always have 2 parts to every assignment. We have assignment 1A and assignment 1B, assignment 2A, assignment 2B. And the main reason for that is just to make sure that people don't procrastinate and that you're keeping up with the assignments. So each piece won't be that long, but I just have them pretty much every week so you don't fall behind and then try to pull an all-nighter at the last minute. Do not miss deadlines. I cannot stress this enough. You absolutely have to follow along with the Piazza discussion boards. Do not check those every day, several times. Make sure you read the questions and responses, and make sure you post your questions there as well. We'll talk about that in a second too. Participate in the discussions, both in class and on Piazza. You can go to the link here down below and get access to Piazza. I subscribed everybody, so you should all be there. If you're a late joiner, let me know and I'll make sure I add you to the discussion forum. And there's also just enormous number of resources available for you in this class. We've got the office hours. I have my office hours before class. If you can't make those for some reason, let me know. I'll be happy to reschedule another time with you. We have the discussion forum. We have zillions of links in the slides that you can click when you download the PDF versions. Obviously, all the videos are going to be recorded and produced in a nice, easy to digest manner. And then there's also some sort of, textbooks, which are really there as supplemental resources. You probably can do well in the course without getting into the textbooks, but the Modern Java in Action book is a really good book. So if you have a chance to get that book, I strongly recommend you get it. Please resist the urge to email me directly unless you want to schedule a meeting or unless you have something confidential you want to talk about. It's not that I don't want to interact with you. I want to interact with you, but my experience has been using the Piazza discussion forum is by far the most efficient way to interact. And so you're welcome to post anonymously. That's not a problem, but please post general questions to Piazza, and then either myself or other students or the TAs can jump in and answer. And that way, when other people have the same questions, which is very common, there'll already be a history of the responses. If you have questions about specific source code where you're like, my source code isn't working, it's fine to send those to me privately on Piazza because you might not want to disclose your solution to everybody unless it's so badly broken that people won't be able to plagiarize your code and get their solution to work. But it's not that I don't want to interact with you. I just want to make sure that we do it in a way that will be most beneficial to everybody else, since we're doing almost everything remotely, or I guess we are doing everything remotely in this class. Last point before we wrap up and I take some questions. Why should you be excited about this kind of stuff? Why is this material so valuable? There are an enormous number of abundant opportunities for people who learn the material that we're covering in this class. And if you take a look at some of the latest market research, people have found that students with computer science degrees and more generally engineering degrees are doing very, very well, even in this world of pandemics and lockdowns. And that's largely, of course, because those of us who do computing can be productive pretty much anywhere. We can be productive at home. We can be productive in a coffee shop. We can be productive just about anywhere you go. So that is hopefully a strong motivator to really learn the material and master the topics that we're going to cover. Okay, so that is the end of